Alright, this should be recording. We'll see how this works. So, hello, hope your concert goes well. Let's take a look at this. How many of you tried to get this into standard form by completing the square? Okay, I think the majority did. There was more than one way to do this though, and I actually want to look at both ways. Okay, so since most of you tried to get in the standard form, let's go with that method first. We have f of x equals, what I'm going to do is I'm going to leave the 1 kind of hanging out here, and I'm going to factor out the negative 1, and I have x squared plus 4x left in the parentheses. Okay? So then I have to think, alright, what do I have to add to this to complete the square in the parentheses? And you all say?
4.
4. Thank you, all of you.
You're welcome.
Alright? So we have x squared plus 4x plus 4 plus 1. Okay? But we need to balance this out because we can't just randomly add 4 wherever we want. Okay. So what did I actually do to this side of the equation? I actually subtracted 4. Notice this positive 4 is being multiplied by a negative 1. So I actually subtracted 4, which means I need to add 4 on the same side to keep this equation balanced. Because now I just added a form of 0 to the equation. Okay? Now I've got my standard form. F of x equals negative x plus 2 squared plus 5. Okay? Now we have it in vertex form. Okay? So, now we can identify our vertex. Our vertex is?
Negative 2, 5.
Negative 2, 5. Good. Negative 2, 5. So, negative 2, 1, 2, 3, 4, 5. There's our vertex right there. And I can also find my zeros. We set this equal to 0. We're going to subtract the 5, divide by a negative 1. So that takes care of the negative 5, makes it positive 5. So we have 5 equals x plus 2 quantity squared. We square root both sides and get x plus 2 equals plus or minus root 5. And then we subtract the 2 from both sides. So I'm going to subtract the 2 there. Subtract it from that side as well. So our zeros are at negative 2 plus radical 5, 0, and negative 2 minus radical 5, 0. Which radical 5 is about 2.2. So if we rounded it, we would have a negative 4.20. 2.236. We'd have 0.20. Okay? So right here, and 1, 2, 3, 4.2. There's our other 0. We'll label those with a Z. Okay? And there's our parabola. Okay? Any questions about what we've done there? Okay. How do I know my zeros make sense at least? Where my zeros are makes sense. Okay. It's opening downwards, so I know I should have zeros. My axis of symmetry, right? If I got 1, 0 here and 1, 0, let's say I accidentally got my signs messed up and I got positive 4 and negative 0.2. Does it make sense to have zeros there and there when my vertex is over here? No. Okay? So, keep in mind what we've learned to make sure your answers make sense. Now, I also want to look at how we would address this one if we had left it in general form. Let me group this all together, and I'm going to shrink it up and move it to the side so we can work, okay? If I were doing this one in general form, the first thing that I would do is to find the zeros. And how would I find the zeros?
Put y equals to 0.
Mm-hmm. And then what?
Can you factor out the -1?
We could. What's an easy way to solve quadratic equations?
Quadratic.
The quadratic formula.
Oh, joy.
Okay? Negative b plus or minus the square root of
Or
b squared minus 4ac all over 2a. Right? Do we all remember our quadratic formula?
Of course.
Alright, we should. If you don't, get on YouTube and look up the Lego quadratic formula song. The guy made a whole little folk song of the quadratic formula, and he even has little Legos in a animated cartoon, or actually it's not a cartoon, it's stop motion animation. He did a whole little story for it. So maybe a stupid story, but you'll never forget the quadratic formula again. So but anyways, we use the quadratic formula. X equals -4, so positive 4, plus or minus the square root of 16 minus 4 times -1 times 1 is plus 4, all over -2. 2a is -2. Okay, so we go on and simplify this, and it actually simplifies down to -2 plus or minus radical 5. I'm skipping some steps, but there you have it.
How
And
did
that's
you get that?
come on. This is radical 20, right?
Yeah.
Radical 20 is the same as
Oh,
Two
you
root five.
simplify.
2 root 5.
Oh, okay.
Okay. And then as long as I cancel out a 2 from both of these, I can reduce. So that would be -2 plus or minus, then the -2 cancels out with the 2 there, and it's a radical 5.
Wouldn't it just be?
Yeah, it's
Well, and since it's plus or minus, the sign, I mean, I guess you could call it minus or plus now, but you get the same thing.
Wait, wouldn't the minus sign cancel out?
Well, if this canceled out that minus, it would make that plus negative. So, I guess if you wanted, you could write it as, now it's 2 minus or plus radical 5, but you get the same thing. Now, does anyone remember a way to get part of your vertex from this form?
Negative b over 2a.
-b over 2a. How many of you remembered that there was something? Okay. How many of you actually remembered what it was? Okay, some of you. Alright. The reason why I wanted to show you this is because a lot of times we forget that, remember h, the x-coordinate of our vertex, is -b over 2a. Okay? This is where if we understand, we actually could remember this pretty easily. I'm going to erase all of this real quick and go back to my quadratic formula. I see a -b over 2a in there. It's right here. Okay? Basically what I did is I took this big fraction and I wrote it as two fractions added or subtracted together with a common denominator, right? So that's legal to do this. But notice, this is my h. This is how far away from my axis of symmetry each of my zeros is. So here's h, this is the negative b over 2a. This is that minus b squared of b squared minus 4ac over 2a. This side, this distance is the plus square root of b squared minus 4ac all over 2a. Okay? So this tells you your axis of symmetry, where your vertex is. Okay? This part tells you how far to the left and to the right you have to go to get to your zeros. Right? If you keep that in mind, then if you know your quadratic formula, you automatically will remember how to get h. And then you don't have to try to get it into, you don't have to try to complete the square, right? Because that's what most of us messed up on. We lost a negative somewhere in that whole process and it messed the entire thing up. But if we can pick out what h is right here, we don't have to worry about completing the square anymore. Okay? So, just a point there I wanted to emphasize. It's helpful to know how to do things multiple ways, but it's also important that we understand. In math, one thing I hope you're realizing is that the more you understand, the less you have to memorize. Okay? I actually don't have a really good memory. I always hated having to memorize lots of stuff, okay? But I can figure things out well. So, you know, the more you, and the reason I can figure things out well is because I understand them, all right? So I may not remember what, you know, let's say on the off chance I forget what 12 times 8 is, all right? I may forget that, but I remember 8 is 2 times 2 times 2, so I just double 12, double 24, and then double 48, and I get 96. Okay? I don't have to memorize it if I can figure it out. So, we don't have to memorize negative b over 2a, or some of these other things, if we understand where it comes from and understand how it all works together. Okay? Any questions? Haven't